So the schedule today began with a race through a bunch of productivity features, and then a dive into creating effects. And now we switch to a little bit more slower paced dive into addressing and racking. And I say a little slower paced because I'm not going to try to show you too many different things. But the things that I am going to show you are really important if you want to understand how Finale works for addressing and racking. We'll progress in two parts. Part one, we'll walk through addressing without racks. And then in part two, we'll walk through addressing with racks. People have been addressing without racks for years. So you might be wondering why I have a picture in the slide on addressing without racks, a picture of a rack. The reason for that is that even if you are using software that doesn't take into consideration racks for addressing, you still have racks. It's just the software isn't taking care of it. You're taking care of it in your own head, or you're taking care of it in how you use the software.
Hey, Will.
So for addressing without racks.
Will, I think do you mean to be sharing your screen?
I do, thank you. Sorry about that.
Oh, no worries. It's all good.
Okay. For addressing without racks, I'm showing a picture of a rack because you still have racks. It's just the software isn't taking the racks into consideration when it assigns the addresses. So people have been addressing this way for years. So we'll begin with that. We'll walk through, make sure everyone understands that, and then we'll layer in racks after that, and you'll see what additional benefits you get from that. So for part one, for addressing without racks, we're going to walk through 4 different workflows of how you can assign firing system addresses. And then we'll walk through 5 or 6 different real world problems that is kind of where the rubber hits the road, or the real nitty-gritty of assigning firing system addresses. And then we'll conclude by just pointing out a few of the things to remember from this talk. Okay, so for the 4 workflows, software for assigning firing system addresses has been around for some time, and different companies and different people have different techniques of assigning their firing system addresses. The techniques fall into 4 major categories, basically beginning with the simplest of just typing in numbers, to the second of typing in some numbers and then filling down as a mechanical operation like you might do in Excel. The third is using a function of the software that assigns firing system addresses for the entire show. And then the final is using the software to assign firing system addresses using different rule sets for different parts of the show. For example, you might have one rule set for how you want to assign firing system addresses for a front, and a different rule set for how you want to assign firing system addresses for shells in the distance. So I'm going to jump into slides and then out of slides to the program, back and forth, to make this a live presentation. So I've just jumped into the program, and we'll begin by walking through those 4 workflows for assigning firing system addresses. We're going to need a show to do it, so we'll create a quick show just by adding some comments. Look for some 3-inch comments, and I'll add them there. I'll duplicate these into some pairs by pressing the D key. Oops, excuse me. I'll duplicate these in pairs by Oh, I'm confusing myself. Sorry about that. That's what I meant to do. I was using a keyboard shortcut and had the wrong keyboard shortcut. Okay, so I've created a bunch of pairs, V-shaped pairs in each of the positions. Now I'll select all of the pairs and put them in a sequence. I'll keep the pairs together by clicking the grouping button, keeps the pairs together instead of putting every shell into a sequence, it's putting the pairs into a sequence, and we'll make the sequence center to outside. Okay, this will serve as an example for us to do addressing in the 4 workflows, because we've got multiple positions, we have multiple effects, some at the same time, some not. Okay, so look over here at the script window in the lower right. We should have 18 rows, and we do, because there are 9 positions, and each position has 2 shells. So in its most basic form, the function of addressing is just assigning a module and a pin number to each effect in the show, so it can be ignited by your firing system. So the first workflow is to just do that manually. I can go to the first effect and just type in a number, and I can copy this number and then paste. So I've assigned module number 1 to all 18 of these effects. And then I can do the same thing for the pins, except since they're at different times, I'm going to use incrementing pin numbers by typing in 1, 2, and then extending this down. Okay, so we just did workflow number 1, and I'm pretty sure that the first show that was ever shot using an electronic firing system probably had firing system addresses assigned similarly to this, just typing in numbers into Excel or to Notepad. I can specify what the firing system is. We'll make this a Fire 1 show, and then export the show. It exports a fire file. Here it is. If I want to take a look at the fire file, I'll use this tool function, which opens up any most formats of scripts from manufacturers. So that even though the fire file is a database file, we can open it up and take a look at it. And this is the Fire 1 script format, and we can see that it calls it slat and Q, we call it rail and pin, but aside from the naming difference, the numbers here are all about the same. They're sorted differently, but it goes from 1 to 18, all on module number 1. So that's the first of 4 methods for assigning firing system addresses. Let's now shift to the second one. The second method is the fill down method. And it's useful because the first method of entering numbers by yourself can get pretty tedious if you want to do something other than just assigning sequential addresses. For example, these first 2 shots are at the same time and at the same position, so they could be on the same pin. Or we may just say that we want to have a different module at each position. So we want to have 9 modules for this show, not a single module. So if I were to use the first method, I could type in 1, 1, 2, 2, 3, 3, and so forth. But it's easier if I can select all of them. That's a very mechanical process. So I can select all the rows, sort by position. So we're going position 1, 2, 3, 4. and then do addressing, fill down addresses in script window. This is a mechanical process that just takes the first address, here 11, or I could change it to something else, and it fills down, beginning with that first row, to the remainder of the selected rows, incrementing pin numbers. Whenever it gets to a change of position, if I have position selected here, then I'm indicating that I want it to advance the module number. So since I'm sorting by position first, it's going to use the first module for position 1, then it's working its way down, filling down, it gets to position 2. That's a change from position 1, so it has to increment the module number, and so forth on its way down. So if I now do fill down, you'll see we get module 1, pin 1 and 2, then module 2, pin 1 and 2, module 3, pin 1 and 2, and so forth. So that's how the fill down method works. And the fill down method is useful. Well, there's an interesting trade-off here between an automated system versus a system that you can manually get anything that you want. Usually the more automated it is, the less easy it is to make tiny changes by hand. So the most basic method of typing in the numbers, I can get anything I want. I'm just typing in the numbers. The fill down method is more mechanical than that, and it's quicker, but it also provides the ability to, say, just select the first 4 positions and fill down, say, beginning with module 10, and then select the remaining positions and fill down, let's just say, beginning with module 20. So if I have in mind specific modules that I want in positions, I might use the fill down method because it's still very mechanical. It's like driving a manual car instead of an automatic car. But there are some limitations to this. You have to sort the rows according to the field that you want to recognize changes of that causes the module number to increase. So we had to sort the rows by the position. We couldn't sort by event time. If we sorted by event time, then the condition that we would increment the module number every time the position changed would increment it here when we go from position 5 to 4. That's going to increment the module. Then it'll increment it again when it gets to position 6. Then we're back to 4 again, so it'll increment it again. So we'll end up getting incrementing modules each time, and we'll end up getting more, requiring more modules than we ought to. So if I select everything and then do fill down sorted by event time, we're going to get a mess here. Yeah, see, we use 17 modules for 9 positions and only 18 shots. So that was not a very good, efficient use of modules. So if you want to be able to sort things differently from the conditions that are causing modules to be changed, you can define a rule set and address the entire show with that rule set. And there's a function in Finale called address show. This is probably the most easy to use way of addressing the show. So even though it's the 3rd on our list, probably 80 or 90% of the people on the call would end up using the address show function more than any of the other functions. It's super easy. Just do address show, pick your firing system, decide how you want the addresses to be sorted, and different companies have different views or different preferences for how to do this. It's common to sort by position first, but after that, almost everybody has a different view. We might sort by angle, we might sort by category next, or hazard field or size. everyone has a different idea on how to sort their addresses. For our purpose, I'm just going to sort by position. That's the simplest. And then event time is the easiest to understand, even though it's probably not what most people do. The third paragraph here is similar. It's analogous to the third paragraph in the fill down dialog that we were just looking at. In the fill down dialog, we define the conditions under which, when filling down, we define the conditions under which the module number would be increased. So that's very similar to what we're doing in the third paragraph here. The language is a little bit different because we're not filling down, it's looking at the whole show. And we're just adding a restriction. So you have to think of it a little bit differently. For the fill down, you're thinking very mechanically. As I'm filling down here, when do I start incrementing? When do I have to increment the module number? When you assign the whole show's addresses together, think in terms of constraints. So do I want to allow a module to serve multiple positions, or do I want to restrict a module to a single position? In this show here, we have 9 positions. If we wanted to have one module at each position, then we would have a constraint here. Each module is restricted to a single position. And this show would take 9 modules to address. If we remove that constraint, then we're basically saying that, look, a module can be shared. It can serve all of these positions. And since there are only 18 shots and there are 32 queues in a Fire 1 module, it's only going to take 1 module for the whole thing. So let's do that quickly and compare. If I add position as a constraint and then address the show, we can look at this summary. It's quicker than looking at the script, and we can look how many modules were required. We had 18 shots in the show. It took 18 pins. It took only 9 modules. That's what we'd expect because we had 9 positions. Also 18 E-matches. Okay, let's repeat the operation. And this time, let's remove this constraint on the module, which is going to allow the same module to serve all of these. And I'm expecting now it's only going to take 1 module for the whole show. There it is, 1 module for the whole show. And if you look over here, the rail column, 1 module for the whole show. So that's the third. Remember, we're walking through 4 different ways of assigning firing system addresses. The third is address show. This leads us to the fourth, which is addressing the show using blueprints. The idea of the fourth is that it makes up for a deficiency of the third. The third, you have to define in this dialog here a rule set that applies to the entire show. So do we want to allow modules to be shared across positions or not? But we're making a global decision. It's possible that your show may be divided into different sections and you want different rule sets to apply to different sections. We'll create an example here. I'll insert a few more positions here and add shells to them. So now here's our show with, well, I'll switch back to the front view. Here's our show with the front, but then we also have 3 shells in back. Imagine that we want to share modules for the front, but we don't want to share modules for the positions in the back. So since there are only 18 shots in the front and we're going to share, we'd like to end up with a single module being used for all of this. And then we don't want to share back here. So then we want a single module for this one and for this one and for this one. So 4 modules total. That's what we want to end up with. So how do we get there? We create two different rule sets with the function create addressing blueprint. Blueprint means template, and in this case, an addressing template is a rule set for addressing. So we'll create addressing template. We'll call the first one sharing, and sharing will not have any constraints here because sharing is allowed. We'll create a second addressing blueprint. We'll call it no sharing. And no sharing will have the constraint that prevents modules from being shared across different positions. We now have two different rule sets. What remains for us to do is to define what positions use the sharing rule set and what positions use the no sharing rule set. I'll right click, these are selected. I'll right click on one and do edit position properties. Since all 9 of these positions are selected, the properties that I'm editing will apply to all of the selected, i.e. 9 positions. And right in the middle of this dialog, it says addressing blueprint. I'm going to choose the sharing blueprint for this section of the show. And that's it. Then I'll select these 3 positions back here, right click, edit position properties, and choose no sharing for these. Now I'm ready to address the show again, but I'm going to use a different menu item. Instead of just addressing show, I'll use address show using blueprints assigned to positions, because I want to use specific blueprints for different parts of the show, just as we defined. Here we go. What I'm hoping for is the end result will be 4 modules. There it is, 4 modules. Okay, terrific. So that goes through the 4 workflows for assigning firing system addresses. Typing the numbers, filling down, addressing the show with a global set of rules, and addressing the show with different sets of rules for different parts of the show. We're now going to walk through real-world examples, and these are all going to be, well, some of them are kind of tricky, and some of them are easier, but they're all interesting, and they're all going to reinforce your understanding of how the addressing system works. The first real-world example that I'd like to show is one that we've done one way already, and now I'm just going to show you how to do it a different way. So the real-world example was sharing or not sharing modules, and the first way that we just did it using blueprints was to define a sharing blueprint and to define a no sharing blueprint and address the show with different blueprints assigned to different sections. I'd like to give another way of doing this because the hobbyist version of the software doesn't support addressing blueprints. That's one of the pro-only features, but being able to share modules is really important for hobbyists. Sometimes it's even more important for hobbyists than pros because their hobbyists are often more limited by the hardware that they have. So I'm going to provide a second way of doing it. The second way of doing it uses the address show function and controls whether modules can be shared by grouping these positions down here into the same, and it's a new word here, section, and then putting each one of these positions as its own section. Now, a section is just a name that we give to a collection of positions. So I'm going to call these 9 positions section A, and then I'm going to call this section B, and then section C and section D. So there'll be a total of 4 sections. And then if you actually read the small text here, it says each module is restricted to a single, and then the word section. and X, Y, and Z, and 3 fields that I can fill in. But section is always here. I don't even have a choice. It's always the case that modules cannot be shared across sections. So when I told you that sections were just a name, that's true. They are just a name, but they also relate to the addressing system in this very useful thing that modules can never be shared across sections. So here we go. Let's select these positions just like before, right-click, edit position properties, and set their section to A. Then I'll click on this position, right-click, edit position properties, set its section to B. And I would right-click and set this to C and this to D. But instead of doing that, I'm going to show you a trick, a more efficient way to do this for a large show. I'll bring up the positions window where I can see my positions here, 1 through 12. And I can edit directly in this window. It's a little quicker sometimes than right-clicking and editing position properties. Here are my 3 shell positions. I wanted B, C, and D. I'm just going to type those in. And also I can see where I had assigned to these positions the blueprints for the pro users. So since I'm addressing this time, pretending I'm using the hobbyist version of the software, I'll just delete those. And we're going to accomplish the objective just using the section numbers. Address show. And no constraints here because we're allowing modules to be shared across positions. The only thing that's restricting modules from being shared is the section numbers or the section names, of which the whole front is the same section and the others are independent sections. So when I address this, I'm also expecting to get 4 modules. There are 4 modules. And you can see it's also giving me a summary that we're using 4 different sections. Okay, terrific. So that covers the real world example of sharing modules or not across positions. An analogous decision applies to sharing e-matches. And for firing systems that have modules and slats and pins, there's also an analogous decision for sharing slats. Let's dive into using multiple e-matches and sharing them across the show. This is a good show for demonstrating using multiple e-matches because we have pairs of shots at each one of these positions, each pair at the same time. So if you're trying to economize your use of firing system pins, you might choose to use 2 e-matches in series for each pair. Okay? So when I address the show, I can control whether e-matches, multiple e-matches can be used on a single pin or not by way of this field right here. It's currently set on 1, which means each e-match is going to get its own pin. If I change this to 99, making it effectively unlimited, then the firing system addressing function will combine multiple effects or multiple e-matches on the same pin wherever possible. So obviously they have to be at the same time for it to be possible. And it's usually the case, though not 100% of the time, that people always also want to add the restriction that they only use e-matches combined in series for effects on the same position, because otherwise those e-matches would be inconveniently far apart. I'll address the show right now, just making this change to 99 here and making no changes down here. So remember, since we are not restricting modules to positions, there's nothing to prevent one module from serving all 9 of these positions. And there's also nothing to prevent a pin from serving any effects on any one of these positions that occurs simultaneously with other e-matches. Here we go. We're addressing this. Okay, let's take a look here. We used 4 modules as before. That's expected. 1 module for the front and 1 module for each of the shell positions. Here's where it gets a little bit maybe unexpected if you weren't following too closely. The number of used pins is 8. Why is that? Well, it's able to use a single pin for multiple e-matches, even on different positions. So position 1 and position 9 both have a pair of effects that are shot at the same time. A total of 4 effects are going off. Where is that? Position 1 and 9. Center to out, so it's the last one. It's these right here. So those right there. Position 1, position 9 at the same time. So if I look down here at those 4 effects, look at they're the same module. They're also the same pin, even though they're positions that are very far apart. So this is not realistic. We would never want to do this. But when we addressed the show, we didn't create any restrictions to prevent it. We basically said, go ahead and do it. So let's create restrictions to prevent it now. It's really simple. We just add a constraint on the pins to say that each pin is restricted to a single position. So even though a module is shared across all of these positions, the pin cannot be shared across all of these positions. We readdressed. Now we get 12 pins. And let me select these just to take a look and make sure. Yeah, look at this. Same module, but position 1 here and here both use pin 1, and position 9 here and here use pin 9. So in the addressing dialog, which of course is also the same or very similar dialog to the create addressing blueprint dialog, to be using different rule sets for different sections of the shell. We have now worked by assigning different restrictions on the modules for some of our examples, and we've worked by assigning different restrictions on the pins. We'll continue to build up doing the same thing, using these constraints to achieve different and advanced purposes for addressing and for racking when we get into the next section. So I'll show you another example here for controlling the sharing of e-matches. It was convenient here that we wanted to limit the e-matches to be shared only within individual positions. So an e-match would not cross different positions. But sometimes even within a position, the designer or the operator may want to have control over what effects are shared on a pin versus what not. You may have a way that works most efficiently for your crew to set up shows. So I'll give you just another way. There are multiple ways of doing this. Instead of restricting a pin to a single position, I'm going to restrict a pin to a single group. Now, if you remember Vitor's talk from yesterday, you can combine multiple effects on the timeline as a group by selecting them. I'll click on this and this to create a pair there. And then I'll go to the groups menu to combine it as a group, and I'll take note that that's the G key, so that next time I can just select these 2 effects for that V, and I'm going to press the G key. Then I'll select the next V and press the G key. Then the next V and press the G key. Then the next V, G, next V, G, next V, G, next V, G. Now, in addition to assigning these things in groups, you can also see that the timeline got easier to read. And if I show one row per group, now the script also became easier to read. Instead of having 21 items in the script, all of those groups is now just one item, one row in the script. See, here it is. And that little 2 there means that there are 2 effects being represented by this row in the script. And it's similarly 2 effects by this bar on the timeline. So we've simplified the timeline. We've simplified the view of the script. Watch, if I turn that off by unchecking show one row per group, then that one row becomes 2 rows. It basically expands or unfolds into its constituents. I'll combine it again. Okay, it's 1 row again. Having now defined these as groups, I can use that grouping as a way of controlling the eMatch combinations by, when addressing the show, restricting a pin to a single group. I expect to get the same answer now, which I think was 12 pins. There were 13 pins. I can't remember exactly, or maybe I did something wrong with grouping. But we've used the grouping to limit the sharing of eMatches. All right, so we've worked through sharing modules. We've worked through sharing pins. We've worked through using groups to share pins. The next thing is multiple firing systems. Drew gave you an introduction to this, but it fits in here, so I just want to reinforce it. If I wanted to make this show use a different firing system for the shells and for the fronts, I can select the shell positions, right-click, edit position properties, and choose, let's say, Pyrodigital for the rear positions. Select these positions, right-click, edit position properties, and choose, let's say, Cobra for these. And then when I address the show, it's going to address the show. It actually will ignore this dialog because I've specifically overridden what firing system will be used at each of the positions. So we'll address the show using both Cobra and Pyrodigital. It's kind of interesting when you look at the script rows here, you can see because the firing systems use different conventions for leading zeros, and actually we can't see it here, but Pyrodigital uses hexadecimal numbers. So you can see that the number format down here is for the Pyrodigital effects is different from the number format of the addresses for the Cobra effect. I can also unhide the column module type. Which tells me that these 3 down here were addressed for Pyrodigital, and the rows up here were addressed for Cobra. When I export scripts for a multi-firing system show, it's going to export 2 files. A CSV file for Cobra and a PDM file for Pyrodigital, and it saves both of those files here on my hard drive. There was a question in the earlier presentation about using universes to support a show that uses multiple controllers of the same type. So we automatically got 2 universes when we said that the positions back here were one firing system and the positions up here were a different firing system, because every different firing system has to be its own universe. But if we wanted to use a different controller of the same firing system for these 2 sections of the show, then we can still separate them into their own universes by assigning the universe field to these positions and a different universe field to these positions. Right click, edit position properties, and it's universe. Like you can just type in, universe number 1 for these, and edit position properties, universe number 2 for these, and even if both sets of positions are addressed for the same firing system, I think I set them both up to Cobra. Yeah, they're all Cobra, but when I export the show, maybe I set them to the same universe. Let me open the positions window and take a look. Yeah, look, I set them all to the same universe. So that was just kind of a typo error. I meant to set them to 2 different universes. So the shell positions would get their own file. Address show. Two universes. Export, now I'm going to get 2 files. Great, you get 2 files. Okay, working through these real world problems. Some firing systems have addresses that explicitly mention the slats, and they have their multi-level firing system, like the FireTech system, with modules that group their pins into slats, and then each slat has some number of pins. It may be useful when we're addressing the show to control where the slats are placed, in addition to controlling where the modules are placed. So I'm going to readdress this show for FireTech with a different set of considerations in mind. I still want to share modules across these positions, but I really don't want to be dragging e-matches between these positions. So I'd like to put different slats at each position. So each position gets its own set of slats, but the modules that are feeding those slats can be shared across multiple positions. Go to the address show dialog. We'll address for FireTech. We'll use the module configuration that has 4 slats per module, and each slat has 12 pins. We will allow modules to be shared across multiple positions, but we will not allow slats to be shared across multiple positions. This is the line that is going to guarantee that each position gets its own slats. So you see, we've now used the different rows in this constraints paragraph to achieve different purposes. I'm going to address here, but I forgot, I've got to get rid of the explicit specification that we're using Cobra on the positions. So I'll go back to the positions window and just delete those. Readdress the show. So here's kind of a math test. How many modules are going to be required to address this show when I click enter? I'll let you try to figure out the answer to that question. There are 4 slats per module, and we've said that these positions down here are in the same section, so they can share modules, but they can't share slats. And these positions up here get their own modules. So I'll give you a hint. I know, since each one of these positions gets its own module, that there are going to be at least 3 modules. And the remaining question to be figured out is how many modules are for down here. Is it 1 module for all? The answer then would be a total of 4. Is it 9 modules? The answer then would be a total of 12. Or is it something in between? Let's find out. 6. It is something in between. Why is that? Well, each slat has 12 pins. There are 4 slats per module. We've restricted slats to be constrained to being in a single position each. So we need 1, 2, 3, 4 slats. For those 4, that's going to be 1 module. Then 1, 2, 3, 4, that's going to be a second module. And then with 1 position left over, that's going to be a third module. 4, 5, 6 modules. So we've now used all 3 of these rows, and we haven't gotten to racking yet for assigning different constraints on the different characteristics that I might want to control while addressing the shell. We used in that example FireTech because FireTech modules always use slats. And in fact, slats are even incorporated into the firing system addresses. You might also have a firing system that doesn't always use slats, but you might be using slats. And you might be partitioning the pins of that firing system into pin groups corresponding to the slats. Let's take, for example, the Fire 1 system. We know there are 32 pins in the Fire 1 system. Maybe we have slats with 8 pins each, and we want to take the 32 pins and partition them into 4 slats. The first slat with pins 1 through 8, the second slat with pin 9 through 17, and so forth. We can use the same logic that we used for addressing for the FireTech system for Fire 1 if Fire 1 addresses had modules and slats, but they don't. They just have modules. So we'll create a custom module for Fire 1. Custom module specification, Fire 1. And this little slug of text down here allows me to define how many slats I'm dividing the 32 pins into. So I typed D because that was the 4th letter of the alphabet, A, B, C, and D, which means I'm going to divide the total number of pins, 32, into 4 different slats named A, B, C, and D. And then over here, the number 8 means that each of those slats has 8 pins, totaling up 32. So I'll address the show now for Fire 1. And instead of using the default module, I'll use the custom module with slats that I just defined. And we'll keep these constraints down here that have a constraint on the slat that says slats cannot be shared across positions. Same numbers of modules as before. And if I look now in the script, I see the rail address is looking a little unfamiliar to me because Fire 1 addresses usually go from 1 to 32, but I'm seeing here the address being written in a different syntax. It's being written with the module number and then an A and a B and a C and a D representing a different slat or a different bank of those 8 pins. This is what would appear on the label for when setting up the show. But when I address a script, a fire file for the firing system, the Fire 1 firing system is still expecting to see numbers 1 through 32. It's not expecting to see anything having to do with A, B, C, or D. So I'll export this script just to show you what happens. Looks like I still have the universes. set up. So we'll address this for Fire 1 again, custom module. And export the firing system script. Just one file. Then if I open this file up and take a look at it with the tool command open firing system script, just to take a look, I wanted to look at this slat and Q number to make sure there were no A, B's, and C's in it. Indeed, the Q numbers are just numbers from 1 through 32, and they're getting kind of grouped out. Number 9 is the first pin of the second slat B, and so forth. So when I export the script, it's doing a translation from what I'm seeing here and what I would have on my labels to what the firing system understands. We're getting to the end now, rounding it out. Lastly, I want to finish with something fairly simple, but that people do a lot. Choosing what modules apply to each position. You're probably getting the idea that when you select edit properties, there's a lot of useful information associated with a position. One of the fields that we haven't typed anything in yet is the start module field. I can choose, I think I'll do it for these guys back here. I'll right click this, edit position properties. I'll make this start at position 20. And then it's particularly easy to do this using the positions window. So there's that 20. Now I'll type 30 here and 40 here. So when the addresser assigns firing system addresses to these positions, it's going to start with 20, 30, and 40 and count up from there. Let's address again. Okay, and we'll take a look down here at the script. Indeed, there's the 20 and the 30 and the 40. Okay, we've worked our way through all of these real-world examples of controlling firing system addressing using properties on the positions and using constraints in the addressing algorithm. The 4 things that I'd like you to remember from this talk are sorts and constraints, in particular constraints, paragraph 3 in that dialogue. Universes and sections. Sections are just a name that you can give to a group of positions, but modules cannot be shared across sections. Universes basically associate with an entire script being exported. So if you have multiple universes, you'll get multiple scripts exported. Position properties is how we defined the universes, the sections, how we define what blueprints apply to what positions if we're addressing the show using different rule sets for different sections of the show. And finally, several times during these examples, I brought up the position window just to show you how convenient it is to edit within the positions window. So that's all we have for part 1 of the addressing and racking talk. I think I mentioned, and Drew mentioned at the beginning of this, that we're going to move the racking section into part 2 to share time with the custom reports, because the addressing had important topics that I wanted to be able to walk through slowly to make sure everyone understands them. So we'll take some questions now. And then we'll take a break, and then we'll come back and do racking and custom reports. Drew, can I switch back to you?
Yeah, sure thing. You can stay on as well, and you might be most qualified depending on the question. I've actually been keeping up pretty well with the questions that they've come in. There's just one active question at the moment, which is the refresh firing system type on the to-do list, refresh firing module type, to enable Fire1 users to change between fire file, a .fir, and a .sem without having to readdress to show or copy paste the module type.
Yeah, I understand that. And the answer is yes. So we've gotten that request from a few people, and we think it's a great request. So it is on our task list, and we'll be working on that in the polishing. It didn't make the hot list, so it's not in the next month, but it is on the polishing list.
Perfect. Someone's asking about custom labels, so I guess maybe you can tee that up in the next session.
Great. I'm not sure if we're going to be able to cover labels. So we've got a limited amount of time in the next section, and we're covering racking and we're covering reports. I'm going to show labels. I'll talk about concepts that are important for customizing reports, some of which apply to labels as well. But I'm not planning on covering label customization in detail. Part of the reason for that decision is that we have good documentation for labels customization on the website. I'm going to share my screen again and show you where it is. Okay, give me just a moment here.
And mark that one.
So I'm sharing my screen here. I'm on the Finale 3D site. I go to documentation, software documentation, and then scroll down a bit to reports and labels. And this article here, labels basic configuration, basic instructions. There are a lot of good examples here, and this basically includes the specifications for how to customize labels. So I think you'll be okay. Even if you don't get what you're looking for in this talk, you can refer back to the website. Drew, shall we take a break for a few minutes, intermission, and then come back with the next section?
Yeah, absolutely. I have one quick announcement, and I hope everyone is really excited by this. I went ahead and rendered out the demo video that you saw at the end of my last session, which was session 2, into HD and put that on YouTube. I'm going to send out a link right now in the chat. So if you didn't come through well from streaming through Zoom, you can go ahead and you can go ahead and watch that video. We'll go ahead and start the intermission, but you can watch that anytime you like. Also, I put the fin file, which is the show file for those effects, in the description of the YouTube video, so you can download that directly. Make sure you have the latest version of Finale 3D, though. Otherwise, some of those effects won't look correct. So I'm going to go ahead and put that into the chat right now to everybody. So if you look at the chat in Zoom, you will see a link to that YouTube video. I hope you enjoy that. And with that, we'll go ahead and jump to a quick intermission. I'll go ahead and share my screen.